Done.
Done. 2, 3. Is it matching?
Yes.
Fine. So this is how we draw. Basically, for learning the organic compounds, you should know how to draw, display, the structural, and all those formulas. Right. So this is very easy actually. Now we are moving to the next part in this, that is homologous series. You might have heard about homologous series, right?
Yes.
Have you heard about functional group? What exactly is a functional group?
Yeah, like alcohol.
Mm.
Mm.
Which will give the carbon chain a new chemical property. Like if you attach OH, become alcohol. If you attach, acid, carboxylic acid, it will give you acidic property. So those functional groups are going to give special characteristic. We can say that. Right. On the basis of the functional group, we have this homologous series. What exactly is this homologous series? For better understanding, I'll tell you. In homologous series, the carbon chain differ by CH2. In homologous series, the carbon chain, you can, if you want to write, you can just write it. Series, the carbon chain differ by CH2.
Yes.
All right. Now, if I'll tell you exactly how the series is occurring, I am just taking this homologous series without functional group. Okay. I'll tell you about the functional group also when you are keeping the functional group in this homologous series. But for now, I'll just take the simpler form. That is, let's take ethane. Ethane is written as C2H6, right?
Yeah.
Then you can take propane, that is C3H.
Eight.
Yeah, all right. Then you have the C4H,
10.
right? Now, go on. Then you will subtract C3H8 with C2H6. Okay, 8 minus 6, you'll get 2, 3, 2, 1. So, if you see, this is differing, this both are differing by CH2 unit, right? Next, if you go on C4H10, and that is again the same thing, subtraction if you are doing, you will get the same thing, that is CH2. So
CH2.
in the series, one carbon chain is differing from the other carbon chain by CH2 unit, and this is what makes a homologous series. All right. Here, if you see, we are increasing the carbon number, hydrogen number. That can happen. That can happen. But let's suppose if I added OH over here, that is basically alcohol group, right? Alcohol or functional group, if I say overall, that OH will remain same. You are not going to, you even you know very well that we never write 2 alcohol, 3 alcohol, 4 alcohol. We don't do like that. Yes, we do when we are doing some certain kind of reaction. We write diol, triol like that. But here in the case of homologous series, you are not going to change the functional group. If you took OH in the starting, you have to take for whole series OH only. All right, you cannot change it. Like basically, the first one, if it is alcohol, the second one should be alcohol, third one should also be alcohol. It cannot be alcohol, ketone, carboxylic acid. That's not true. You can't do that. So in homologous series, if we talk about the definition of this is nothing but related organic compounds with the same functional group. Okay, and this is the best way to identify the homologous series. That is, the carbon chain differ by CH2 unit. All right, this part is fine.
Yes.
All right. Moving to the next, we have this naming organic compounds, which is one of the most hated topic for all the students. Do you hate it? I won't say that, isn't it? Most of the people don't like this because it is little bit complicated if you don't concentrate. But it's very easy, very easy. All right. So in this naming of organic compound, first of all, you have to see few things. The first thing is number of carbons, like how many carbons it has. Okay. On the basis of number of carbons, you will see that whether it is, s- single bond, double bond, triple bond. If it is single bond, we call it as what? Alkane. If double bond, we call them as alkene, right? And if it is triple bond, alkyne, right? So after seeing the number of carbon atom, you have to see hydrocarbons. If I say hydrocarbon, which hydrocarbon is present, basically, right? After seeing hydrocarbon, you have to use root word. Okay, you have to use root word. What is this root word? Basically, if you have only one carbon, okay, for the one carbon, you will have root word myth. All right. For two, you will have it.
It.
For three, what do you have?
Prop.
Very good. For four,
But.
all right. Then for five,
Uh, Prop.
for five,
Pentene.
yeah,
Pentene.
all right. Pent. All right. I am not going little down. I'll just tell you from here only. Let's suppose if you will see the carbon chain, you have to see the formula also. In the molecular formula, they'll help you to identify whether it is, you have to look for molecular formula also. All right. So let's suppose if I gave you two molecular formula, that is C2H4 and then the other one is C2H6. All right. If I gave you C2H4 and C2H6, if I ask you to write the name, first of all, you will write it into the structural form. So if you write this, it will be like this, right?
Yes.
Like this. All right. And this is the first example. And the second example, that is C2H6, CC 1, 2, 3, 4, 5, 6. All right. Now, if you see the on the basis of molecular formula, you will be able to judge whether you have the single bond or double bond. If you see over here, you have double bond, right?
Yes.
So you for writing the name, you have to use the word root or root word, that is it. All right. After writing it, as it is double bond, you have to use prefix, that is ene. Is that fine?
Yeah.
Next one, if you see here, carbon carbon is having single bond. So for writing the name of that, you will use e word
And.
root, yeah, ane, right? For if suppose it was alkyne group, you will be writing it as ethyne, isn't it? So this
Yeah.
is how we name the organic compound. It is very easy. The complexity starts when we learn about this functional group, right? I'll give you one example. Please tell me the name of that. E7H16. What is the name of this compound?
Heptane.
Yeah, all right. C7H14.
Heptyl.
Heptine or heptene?
Ene.
Yeah, all right. Fine. So this way you can just, identify. Now, the next one is how you will name on the basis. You know that compounds generally they are not found in the straight chain. So how you are going to, name them. Let's suppose if I take example. All right. If I take example here, that is CH3, CH, CH2, and then you have CH2, CH3. All right. And this CH is joined with CH3, right? First of all, what we are supposed to do, we are going to count the number of carbons, right? All right, I'll just write rules over here. But rules, if I write directly, you won't be able to process it. So on the basis of example, I'm going to write it out. Okay. So the first thing you have to do is count the number of carbons. All right. After counting the number of carbons, you have to, number it. That will be numbering carbon chain. How you are going to number it? For numbering the carbon chain, you have to look for the alkyl group or functional group. Okay. After finding alkyl group or functional group, you have to assign them the least number possible. What did I say?
A least number.
For whom?
The carbon chain.
To the functional group or to the alkyl group. All right. You have to try that. If either one of them is present, it will be very easy for you to number it. But when both of them are present, you have to try to give the numbering in such a way that both of them should get the least or lowest number possible. Fine. What
Yeah.
is alkyl group? How do we define alkyl group?
3 triple bond.
Um, three triple bond alkyl. No. When we talk about alkyl group, no, alkyl group is a derivative of alkane. Derivative of alkane. Now, what exactly is this derivative of alkane? When you will remove one hydrogen from alkane, that will convert into alkyl group. Okay, remove one hydrogen, you will get alkyl group. Okay,
Yeah.
so get alkyl group. All right. So generally, how do we write methane?
CH4.
Right. So example, if we write methane as CH4 for this is methane. All right. So for making this into alkyl group, you can just write CH3 like this. Dash is indicating that carbon is having one vacant orbital which will be filled by one or the other anything like functional group or anything can fill it up. So this is your methyl. Okay. For naming also, what you can do, you just have to look for which hydrocarbon or which alkane it is. If it is methane, the group you will receive is methyl. If you will get the ethane, it will be ethyl and so on. All right. Now, according to the rules which I have written for now, can we start naming this?
Yes.
Okay. So from where I need to start? Right hand side, left hand side.
Left hand side.
Okay, from here, right? So why we are starting from there?
For the least number for the alkyl group.
Yes, good. So here you have alkyl group on the second position. So for writing the name, you will start with the alkyl group. So that is also one of the other rule. Write the name of alkyl group first. Name. All right, fine. So I'll write which position it is present?
Second.
Second. So we will write as 2. Which group? Which alkyl? Methyl, ethyl, propyl, butyl. Which one?
Methyl.
2 methyl. Okay.
Pentane.
Pentane. Right? Pent
Yes.
5 carbon ANE because it is having single bonds. All right. Is that fine?
Yes.
Okay. Shall I scroll it or you are writing this thing?
No, you can scroll.
I'll give you example now. You have to tell me the name for that. Example is CH3, C, CH3, CH3. Then you have CH, CH2, CH3, and this is CH3. Yeah.
2, 3 trimethyl pentane.
2,3 trimethyl pentane. Okay. Um, just a minor mistake. Pentane. you have mentioned only two positions, right? But it is written try. So you have to mention in the second position up and down when you have this, right? So you'll write 2, 2, 2 comma 2. Like that
Yeah.
we are supposed to write. Okay, one more is CH3, H, H, CH3, CH2, CH3, and here you have CH3. Yeah.
3-ethyl 3-methyl pentane.
3 ethyl. Okay. Then 3
3
methyl.